In 3, 2, 1. Hi everyone, KNWA and Fox 24 Chief Meteorologist Dan Skoff. My heart and thoughts and prayers go out to those affected by the tornadoes yesterday. What a deadly day in central Arkansas, northeastern Oklahoma, southeastern Kansas. Just a devastating day. But as with any weather event, I like to go back, look at the data, see exactly what transpired, what led to the violent tornado that moved through central Arkansas, also the EF2 tornado. It's been rated in Baxter Springs. Still no word yet at the time of this recording at the rating as it moved into the Quapaw area. Most likely it's going to be around EF1, even EF2 damage, but the Weather Service out of Tulsa will be surveying that. But I want to give you some insight as to the mind of a meteorologist and show you the conditions that led to those really significant storms and deadly storms in central Arkansas. First of all, we're going to start you off with the visible satellite. You know, we always talk about it, cloud cover. What is the cloud cover looking like, and will there be peaks of sunshine? Well, it was an interesting day yesterday on Sunday, April 27th, 2014. You'll notice, first of all, these bright white clouds that kind of look like a shadow. That's actually the sunrise in the eastern horizon and the shadow from the anvil being cast to the left of that anvil. And there you can see that shows the literally the three-dimensional appearance of that visible satellite. Also, the whiter cloud tops in south central Oklahoma, those are developing thunderstorms. Those did move into the northwest Arkansas area. You'll also notice a lack of cloud cover over northwest Arkansas. In fact, I'm going to go ahead and zoom in and you'll get to see that lack of cloud cover. So it was sunny. We were a little concerned that we would see potential for significant severe weather in northwest Arkansas. Throughout the morning, though, cloud cover started to build in. There was also a little bit of a boundary that developed. Another interesting thing to note, you can actually see the boundaries that have developed in a west to east fashion. That's located over west central Arkansas. That boundary extended all the way into central Arkansas as well. I'm going to redraw that with a different color so you can see exactly what I'm talking about. There's those boundaries that are basically oriented from west to east right across northwest Arkansas, and those played a big role in the severe weather severity of the storm. So watch as the cloud cover kind of rolls through. We got the round of storms. You'll notice the brighter, whiter cloud tops. Those are the thunderstorms that moved in during the early afternoon. We had multiple waves of thunderstorms. Okay, so let's fast forward to about 1 o'clock Sunday afternoon. You will also again notice a lack of clouds except for a few high clouds in northwest Arkansas. A very strong thunderstorm complex in central Arkansas. You can literally see the anvil from that thunderstorm, which is what I'm circling right here in west central Arkansas. And then we're looking at this in eastern Oklahoma. This is called a cumulus field. And a cumulus field is what storm chasers and what meteorologists look at to see where developing thunderstorms will occur. Now, as we put this into motion, you'll notice the bubbling cumulus field getting a little bit what we call agitated. This is the developing thunderstorm complex, but you'll also notice some very impressive cumulus towers starting to go up in west central Arkansas. This is initially where the severe thunderstorm that produced the long track tornado did develop. I'll show you the radar here in just a second. So we tick away time. 4 o'clock in the afternoon, we had Brendan Lindsay, one of our storm spotters that was positioned in southwest Missouri. He was watching this agitated cumulus field as well. I'll zoom in on that and you get to see, there you can see those bubbling cumulus clouds. So those storms really took off at about 4 or 5 o'clock in the afternoon. At this point, we started to get severe weather, and you can see actually these dark spots in the visible satellite image. Those little brown areas or little black areas are what we call overshooting tops, and it's the shadow that's being cast with the sun angle being a little bit lower. And so those are overshooting tops, literally the thunderstorm that is climbing well above the tropopause. So we move along in time. Notice this. Right here, southwest of Hot Springs, that's that strong thunderstorm that will eventually go on to produce the Valonia as well as the Mayflower tornado, the Mayflower-Valonia long track tornado. The other storms over northwest Arkansas starting to weaken, including the one that was west of Fort Smith. In fact, that just completely dissipates. And we move along in time, and you'll see those thunderstorms starting to weaken in northwest Arkansas. A lack of thunderstorm development. Tried to get going over eastern Oklahoma with that agitated cumulus field, but thankfully we really dodged a bullet, and none of those storms ended up producing. Finally, the last one, just to the north of Hot Springs. This is the storm that eventually produces the Mayflower Valonia tornado. And you can see as it's moving through, look at all of those shadows. These are very high cloud tops, nearly 45, 50,000 feet tall, what we call overshooting tops. It's an indication of an extremely strong updraft. So that's a little bit of insight into the visible satellite. Let's take a look at the water vapor here, and you'll notice one of the things that we like to look at as meteorologists is the water vapor imagery. And water vapor really tells you the way the air currents are moving. So we have on the water vapor at about noon a big line of thunderstorms. See those green colors? That indicates very cold cloud tops. As we push along in time here, 1 o'clock in the afternoon, the storm started to clear out. And next thing you know, we got more thunderstorm development. Now I want you to focus on this area in south central Oklahoma. You can see just a little bit of extra brighter white located over the Ardmore area. This is what we call a jet streak, or a vortmax, meaning a special spin in the atmosphere that will create a little bit extra lift. Notice how those clouds are getting a little bit brighter and whiter, and that indicates stronger lift, colder cloud tops. Now watch what happens when that streak enters into southeastern sections of Kansas and northeast Oklahoma. Just an eruption of those thunderstorms. This is eventually the complex that will lead to the Quapaw tornado as well as the Baxter Springs tornado. Not a very strong storm according to the water vapor imagery, but it was strong enough obviously to rapidly produce a tornado. Move along in time and you just see explosive thunderstorm development over south central and central Arkansas. That led to the Valonia tornado. So that's the water vapor imagery. We'll go back in time and we'll see what energy led to that thunderstorm complex. You can kind of see this dark spot over central Texas. That worked its way eastward, eventually led to very strong thunderstorms. So what was the reason for the lack of thunderstorms across northwest Arkansas? It all had to do with a southwesterly wind in the low levels. Southwesterly winds in the low levels led to warmer air. That's what we call a cap. And the cap finally weakened once there was enough forcing, but it was by that time it turned into a linear thunderstorm complex. In fact, we'll look at the radar imagery and show you. Obviously everything is quiet now except for tornadoes that are developing and occurring in Mississippi and Alabama. So we're going to go back in time and we'll show you thunderstorms, 7 o'clock in the morning. There's the round right there, moving through at about 1 o'clock in the afternoon. Finally, we had more shower and thunderstorm activity. This was the tornadic thunderstorm that was warned in southern Scott County, northern Polk County. That made its way eastward, dissipated rather quickly, and here you'll see the development of the Valonia tornado, and that was a very intense supercell producing a long-tracked violent tornado. The two storms that produced tornado warnings, as well as the Baxter Springs tornado, doesn't look overly impressive, but the environment was very ripe for tornadoes. The nose of the jet stream was located right in that region. That's exactly why those thunderstorms did erupt so fast